बेटा सिस्टम का ये जोड़, तेरे हाथ में ये सब गोल, तू है भटका हुआ भूगोल, देगी तुझको बस ये दुनिया खूब निराशा खूब हताशा, खूब निराशा खूब हताशा, मत सुनेंगी ये धुनेंगी, तू बढ़ता जा बस बढ़ता जा, क्रैक करते जा, जोर लगा तू जोर लगा, कुछ कर जरा कुछ कर दिखा, किस्मत तेरी मेहनत बन के मौका बेटा लाई है, क्रैक करते जा, चैलेंजेस उठाया जिससे ट्रॉफी भी उठाई है, क्रैक करते जा, अंदर की आवाज सुन तेरे भी।
Hello everyone, welcome back to Unacademy. Today I'll be discussing, in this lesson I'll be discussing questions on magnetic coupled circuits. I already discussed the part 1. In the part 1 I discussed basic questions, how to find out the inductance, with the coupled inductance, not for actual inductance, I mean uncoupled one, it's a coupled one. Okay, when there is a magnetic coupling, then how to deal with those kind of circuits, how to find out the equivalent inductance. Beautiful questions, very different questions. Those questions I think they are very clear. Now I'm with the next topic, a continuation to that. I'm with the continuation to that. I'll be discussing about a little higher level questions. I mean, how to write KVL, KCL, how to write KVL equations and mesh equations, how to find out the current from there and voltage, all this stuff. Okay, let's get started. So magnetic coupled circuits, KVL, KCL, sorry, not KCL, KCL is simple, KVL, because voltage is the one which is getting affected due to the mutual inductance. Okay, so they're a little tricky. I'll just reveal all interesting points, where you need to emphasize those points. I'll just highlight those points. I'll tell you how to approach this, or how to approach for finding out KVL. Okay, with that you can very easily understand things. Let's go to the first question. Look at this. Determine V0 for the following coupled circuit. This is a coupled circuit, what is given. In that you need to find out what is V0. This is a V0 value. You need to find out this V0. So how do you find out this V0? First, find this current. So V0 is equal to, simply I can write V0 is equal to current into this entire impedance. That's what V0. Or else you have another way. You have another thing. This voltage plus this voltage will give you total voltage V0. Okay. Any other thing you can do it. So for finding out again this voltage and this voltage, you'll have to know this current I. So the first thing what you should find out is, you should find out this current I. It's simple loop. Only one mesh is there. You write mesh equation for this. You simply write mesh equation. That's it. Okay. So how to write a mesh equation? Right? What's that? If I take this one as, I'm taking maximum values. I'm following with the maximum values. So 30 at an angle 0 degrees. I'm supposed to take here RMS value. Okay. But let's write it in a maximum values. So the result also will be in the maximum value. That's it. So 30 at an angle 0 degrees. So if I write a KVL to this loop perfectly, minus 30 at an angle 0 degrees, current is going this way. So plus I into 1 into I, or I into 1, it's simply I. Here the point, plus, careful, plus, I'll be writing this part. This will be the voltage across this. Let me write it as V1. Let me write it as V1. Voltage across this, let me write it as V1. So plus V1. Voltage across this, current is going this way, plus minus, is also plus V2. This is some voltage V2, plus V2. Then this voltage I can directly write it. This is C. This is C value, not XC value. This is not XC value. Okay. This is not XC value, this is C value. Omega is 2. XC is equal to, XC is equal to 1 by omega C. Omega is 2. C is 1 by 4. You will get 2. 1 by 4. Yeah. You will get minus J. This XC. Let me put this XC value minus J2. Okay. Minus J2. Excuse me, guys. You try to write this equation. I'll be right back. Just solve this. Okay. Write this following equation. Excuse me. Yep. Now where we are, I'm doing here plus, this is plus, current is I, XC value, sorry, this XC value I was supposed to write, right? This XC value is minus J2, right? Okay, so minus I into J2 minus J2I minus J2I is equal to 0. Minus 30 at an angle 0 degrees plus I plus V1 plus V2 minus J2I is equal to 0. Okay. Now you should write V1, V2 values in terms of current. Okay. You should write equation for V1 and V2. That's the main objective. Okay. Let's do that. This is the main tricky part, guys. The process what I'm giving, this process is important. Okay. The process what I'm giving is very important. You should be careful with that. V1 is equal to, it's a coupled circuit. Inductor has, coupled inductance has two voltages. One is self-induced EMF, next one is a mutual induced EMF. Second one is mutual induced EMF. The self-induced EMF is due to the inductance. Let's we don't deal with the inductance values. We deal with the XL values. Okay, XL values. Let's take that XL value because I'm writing KVL. KVL means current into reactance, right? So let's convert this into reactance. 1 Henry, omega is 2, 2 into 1 is 2 ohm, J2O. This is also J2O, this is also J4 ohm. Omega is 2, L is 2, J4 ohm. And here 1 by 2 Henry, 2 into 1 by 2, this will be J1 ohm. J1 ohm. This will be J1 ohm. So now V1 is equal to self-induced EMF. Self-induced EMF we're talking about. This is, I'm talking about plus V1. Simply V1, right? V1. V1 is equal to what? Self-induced EMF is the first part. Mutual induced EMF is the second part. Self-induced EMF is always positive. For this polarity, I'm just talking about V1. Self-induced EMF is always positive. So how much will be this? I into, because current entering is positive, that's true. Passive sign convention is followed. Passive sign convention is followed. Current entering is positive, so I'm taking positive. Plus I into J2 ohm. So simply plus J2 into I is a self-induced EMF. Now for mutual induced EMF, let me just give the value. We'll talk about the polarity a little while later. J current in this is how much? I'm talking about mutual induced EMF because of this. I'm talking about mutual induced EMF in this. Mutual induced EMF means due to this current, J into I into J4I. Okay. So now the polarity, which polarity should I choose? Additive polarity or subtractive polarity? Means is it a positive coupling or a negative coupling? Look at this, positive coupling or negative coupling. Current entering at dot, current leaving at dot. So it's a negative coupling. So right here itself, that's what, in the part 1 I said it, it's a negative coupling. Directly put here minus, that makes things very simple. If you put minus, whatever the polarity here, the same polarity you can keep it. That's the best one. Okay. keep for this mutual coupling, you keep directly what type of coupling is this. Done. Now V2, voltage across this, self-induced EMF, current is I plus J into 4I plus J4 into I, negative coupling minus J into, mutual induced EMF will be same for both, mutual induced EMF will be same for both. Okay, 4I. Okay, excuse me, I'm getting a call, let's take it. Hello, hello. अभी थोड़ा बिजी हूँ भाई, 1 घंटे के बाद होगा, अभी क्लास में हूँ, मैं आपसे पूछा था ना 3 बजे आने के लिए, ठीक है, अब नहीं हो गया. Sorry, there are a lot of distractions, this bloody phone. Yeah, this is done, this is 4 into I, that's it. This is what? A self-induced EMF, and this is, why I written 4I here? No, this is not a 4I. Why I written 4I? J1I. This bloody phone, you know, once I get distracted, it's gone. J into I simply. J into I simply. J into I simply. Here also J into I. Because mutual inductance value is minus J, I'm putting this minus J. Previously I had taken this J4, that's wrong. Here J4, self-induced EMF. These two are the self-induced EMF, these two are the mutual induced EMF for these two coils. Okay. Now you need to substitute these in this and solve it for I. Just do that. Means I'm substituting here minus 30 degrees, minus 30 at an angle 0 degrees. Here the important note is this is a maximum value. This is a maximum value. Voltage we have considered is a maximum value. That's the main point. Next, plus let me combine these two i's. If I take common I in all these, substitute here, take out I common. Okay, I'm just substituting V1 V2 here and taking I common. You get 1 plus this will be, you will be getting simply plus J plus Ji. This will be getting plus 3Ji plus J3I. That's better, I think, plus J3I. Okay, adding these two, V1 plus V2, you will get plus J4I. I is already out. Done. So this is done, this is done. Next, minus J2 is equal to 0. Okay, then if you simplify it, you will get I is equal to, just simplify it, 30 at an angle 0 degrees divided by 1 plus J2, which is equal to, if you solve it, you will get 13.41. Let me write here. You will get 13.41 at an angle minus 63.43. Okay, this will be the answer. This will be the answer for what? This is the current value. This is the current value. Now tell me, I have chosen here a maximum voltage. So this current is the maximum value of the current. Maximum value of the current, because I have taken here maximum value. If I would have taken here RMS value, this would have been the RMS current. Okay. Next one. Current is over. Once you get current, I can now find out this V0. V0 is equal to V2 plus this voltage. This voltage is minus J2I. This part is V0. Right? V2 plus V0 is equal to V2 minus J2I is equal to V0. Okay. I value is known to you. You can find out what is V2. Okay, let's do that. V2 is equal to V0 is equal to V2 plus V2 minus J2I V2 value is J3I, so take out I common. J3 minus J2, you will get J. So V0 is equal to Ji. Okay, so Ji means J is what? 1 at an angle 90 degrees J is 1 at an angle 90 degrees into I value is 13.41 at an angle minus 63.43. This is the value of V naught. If you solve it, you will get, if you solve it, I have value, I'm giving it 13.4 at an angle 26.56. Okay. Here what is V naught? This is a maximum value. Means if I convert V naught into trigonometric form, then you will get simply, I can directly take this value 13.4. I have here cos term, right? Because the function here is given cos 2t. So here also I will get cos 2t plus 26.56. Okay. Though it seems to be a longer process, it's not actually the longer process. It's actual process. As I had to explain each and every point, that's why it took a little longer time. Next questions we can quickly do it. Okay, that's the first question. I took more time for explaining this concept. Okay, I hope these things are clear. If it is not clear, there is no point of explaining it. Just go back and watch it once again, then things will be very much clear. I'm pretty sure about it, because it's after all simple KVL equation. Here the only tricky part is what is this V naught, V1 and what is this V2. That's it. That is the only difference from any other circuit. Okay. In case of a coupled circuit, this V1 will have two terms because it is coupled with two inductors. If it is coupled with three inductors, if this is having coupling with three inductors, you will have three voltages. Okay. One is self-induced EMF, next one is mutual induced EMF. Okay, that is the only thing you should be careful with when you're doing with this coupled circuit. Sometimes they directly ask write KVL equation. We'll see that. Next question. Write the equation for V1, V2 and V3. For this, you try now, right now, equation for V1, V2, V3. Okay. Write the equation for V1, V2 and V3. Just the voltages. You need to write the equation, complete equation. V1 will have how many terms, you tell me? V1 will have how many terms? And V2 will have how many terms? V3 will have how many terms? V1 will have three terms, three voltages. One is due to I1 current, and another one is coupling between these two due to I2 current, another one is coupling between these two, this is I3 current. Okay. Now first one, you should identify the type of coupling, positive or negative. Here I1 is entering at dot, here I2 is entering at on dot, leaving at dot. This is a negative coupling. This is a negative coupling. This is a negative coupling. I1 is entering at dot, I2 is leaving at dot. This is a negative coupling. Okay. And what else you have? This, for this, you find for this, I1 is entering at dot, I3 is leaving at dot. On dot means here I3 arrow is this way. So current is entering here. Current is entering here. I3 is entering at dot, I1 is entering at dot. Okay. So these two are having a positive coupling. Current entering dot, current entering is dot. That's what exact. That's what the dot convention. So positive coupling. Positive coupling means fluxes are additive. Positive coupling. So for this is a positive coupling. For this, current entering at dot, here current I2 is entering at undotted. It's a negative coupling. This is a negative coupling. First thing you should do, this is the first thing, first and foremost thing which you are supposed to do. Alright? Yes, Devajit, hi. Now write the KVL equation for this. For this, you need to write the KVL equation. Okay. V1 is equal to L di by dt. V is equal to L di by dt, we know. V is equal to L di by dt. It has three voltages. One is self-inductance 7 milli. Okay. Or why to take 7 and all? Let's take it as L1. This is L2. This is L3 for the sake of simplicity. Okay. Now you write in terms of L1, L2, L3. Replace L1, L2, L3 with any value. V1 is equal to L1 into dI1 by dt. Current entering is positive. Current entering is positive, right? So self-induced EMF is positive. Now here for mutual induced EMF. For mutual induced EMF, you need to look for polarity is what? I'm talking about this mutual, this line, negative. So put negative here. So negative mutual induced EMF is how much? This is M12. Let's take it as, I think it's good. We have to take it, otherwise M12, M23, we'll have to take a lot of things. 7 milli, I'll take all milli outside. That's better, I think. 7 milli, I'll take all millis outside. Now here minus 3 milli, mutual inductance is 3 milli into D, current will keep I2 or I1? I2 by dt. We'll get one more term. What is this? This term. We have positive coupling, so take plus 9 milli into dI3 by dt. All are in milli. Milli, take it out. This is the answer. This is the equation for V1. Now let's write for V2. For V2, what do you write? What will be the equation for V2? V2 is equal to write for V2, Datta. I'm saying self-induced EMF we will have try V2. Self-induced EMF will be depending on which factor? The generalized one, guys. The generalized equation for this. Generalized equation for this is you always take current inward. Whenever you have plus, this is a polarity, right? This is supposed to be the polarity. Okay, this is supposed to be the polarity. I'm talking about the self-induced EMF. Current here going this way. This is minus I2 I can take. This I will take it as minus I2. Current leaving is I2, current entering is minus I2. No problem. Okay. So V2 is equal to with respect to this current entering, that's a positive one, that's fine. So plus L2, that is 8 into dI2, this is not I2 actually, minus I2, dI2 is d minus I2 by dt. So careful. Current entering is positive. I should take current as in this direction by default. But current I2 has given this way, so reverse one, this is minus I2. This is minus I2. Okay, so I'm using that's why minus I2. Here I'm using that's why minus I2. Okay. Now, what next? V2 minus I2, this is fine. Now we can take a regular one, or if you want to change it, you can change it with respect to minus I2. I repeat, with respect to minus I2, this is a positive coupling. With respect to I2, it's a negative coupling. Okay. So with respect to minus I2, positive coupling means with respect to I2, negative coupling only. When it's a statement wise, it's different. But the 8 dI2 by dt. What about the current direction? You should be careful with the current direction also, right? For V2. Now, this one for mutually with respect to minus I2, this is a positive coupling. With respect to I2, this is a negative coupling. Or else, guys, to make it things simpler, you just do this way. Current is leaving here means I can find out this value. Current entering, this is current entering point. This is positive, this is negative. Okay. So with this is if this is minus I2, the red one, what I have given here minus I2, this is an interesting part. This will be what? If this is V2, this will be minus V2. With respect to this polarity, this will be minus V2. So I can easily find out minus V2. If you want to find minus V2, with respect to this polarity it's all right now. With respect to this V2, current is entering at positive, or you take it as Vx for the time being. You try to find Vx. Vx is equal to, let's write this way. Vx is equal to with respect to Vs, current entering is positive. Current entering is positive, so I don't have to take minus I2. This will be the easiest way. Okay. I'm talking about Vx, guys. I'm talking about Vx. This is, sorry, plus I2. I'm writing again minus I2. I2. Next, with respect to this I2 and this, what's the type of coupling? There is a negative coupling, so put minus here, minus 3 d I1 by dt. Next, with respect to these two, what's the coupling? Minus 4. We have already kept here minus. So minus 4 d I3 by dt, because this is a current I3, d I3 by dt, total milli. This is not the equation for V2. This is the equation for Vx, but it is also to find what is the value of V2. What is the relation between V2 and minus V2? V2 and Vx, sorry. V2 and Vx. V2 is equal to minus Vx. V2 is equal to minus Vx. So in place of here, you put minus V2. In place of Vx, you put minus V2. So V2 is equal to, you'll get this term. That's what you'll get. Here minus, here plus, here plus. If you have taken earlier way also, you'll get the same. Okay, same thing you will get it. Okay, you should be careful with these simple aspects. Tricky parts. Okay, these are the tricky parts where you should be cautious. Next one, V3 is equal to, now you tell me what is V3 is equal to. V3 current entering is positive. So now let me just erase this Vx. Now Vx is done. This work is done. I am erasing it. Okay. Now it's time to take another one as Vx. This, let me current entering. So this is positive. This is negative. This is Vx. Let me take now this one as Vx. I can easily find Vx. With respect to this Vx, I'll have a positive, that's fine. 9 into d I3 by dt. This is the first thing. The second thing is mutually induced EMF. This is a mutually induced EMF. Between these two, what's the mutually induced EMF? Minus 4 into d I2 by dt. Are you following? Minus d I2 by dt. And between these two, we have something. Plus, positive coupling, right? Plus 2 d I1 by dt. Sorry, this much milli. Again, this is a Vx, not V3. Relation between these two is minus. So I can keep V3 is equal to minus of 9 di3 by dt minus 4 di2 by dt. This is the equation. Clear with this? You should be careful when you're writing these equations. This is minus, this is plus, this is minus. Okay. Let's go to the next question. Yeah. Write the equation for this. For loop 1, this is loop 1 given. For this loop 1, what is the correct loop equation? Directly they'll ask you to write the equation. That's it. For loop 1, just write it. It's simple one. This current is given as I1. This current here is given as I2. This current is given as I2. For loop 1, we don't have to consider this. So this current is I2, means current in this is how much? In this is I1 minus I2. I1 minus I2 is a current. So this total voltage V of t will be equal to this voltage plus this voltage. This voltage plus this voltage. Okay. This voltage will have only one term. This voltage will have only one term. This voltage will have only one term. Whatever this voltage will have how many terms? This voltage will have two voltages. Self-induced EMF, and there is a coupling between these two. That's a mutual induced EMF. If they would have given coupling between these two also, you will get 3. It's not given, means it's not there. It's not given means it's not there. So only you will get 2 EMFs for this. Okay, for this, what is the voltage across this? I can simply write V of t is equal to, if I take it as V1, if I take this one as V2, V of t is equal to V1 plus V2. That's it. What's the value of V1? V1 is equal to, simply I can say I into R. I into R. or I1 into R1 rather. This is I1, right? I1 into R. That's it. V1 is over. Now you need to find V2 carefully. Try to find V2 carefully. Okay. V2 is equal to the self-induced EMF. This is the V2. The self-induced EMF, current flowing in this is, I told you, I1 minus I2. Due to this, there will be self-induced EMF L1. L1 into d I1 minus I2 by dt. What is the coupling here? For M12 type of coupling is plus. Current entering is positive, here also current entering. That's dot. Current entering, we have a dot. Here also current entering is dot. So positive coupling. So I'll have plus here, plus M12 into current flowing in this is how much? I2 d I2 by dt. This is the answer. V1 plus V2. So this is V1, this is V2. This is the answer. Okay. Next one. Write mesh equations governing the circuit below. You need to write both the equations. Okay. This is the first mesh. This is the second mesh. Okay. Let's focus on the first mesh first. First, when it's a coupled circuit, so type of the coupling between, what is the type of coupling here? This current is I1, this current is I2. Okay. This current is I1, this current is I2. This type of coupling is, current in this is I1 minus I2. Here positive coupling plus, put this directly. Here type of coupling is between these two. Current is leaving a triangle, current entering a triangle. This is a negative coupling. Sami, I love your pi square channel. अच्छा ठीक है, थैंक यू, गुड. फॉलो करो अच्छे से. अभी अनअकैडमी भी क्लासेस चल रहे हैं, इसमें भी फॉलो करो. सब्सक्राइब करो अनअकैडमी में. कभी मैं हिंदी में भी बात कर सकता हूँ, बात करूँगा, ज़रूर बात करूँगा. ओके, हिंदी का चैनल भी खोलेंगे. अभी इसमें फोकस ऑन दिस. दिस इज नेगेटिव कपलिंग. डन. नाउ once you need to immediately identify this first, then only anything else. Once you get the coupled circuit, you need to identify positive coupling and negative coupling, then you'll go further. Okay, now for this loop we write the KVL equation. Careful. Minus 10 at an angle 0 degrees plus minus plus this voltage how much? I1 into 1 plus I1, and this voltage for now let me take it as V1 plus V1. I'll leave some space. This is V1. Okay, and plus V2 plus V2. Okay, is equal to 0. Is equal to, this entire will be equal to 0. This is what the first loop equation. Now remember point here. This is, yeah, all are fine. All are fine. Minus 10 at an angle 0 degrees. And this way, this way, this way, this way. What is this here? 10 at an angle 0 means what? This is a maximum value or RMS value? This is the RMS value now. This is RMS value because it is given directly in polar form. Okay, that will be the RMS value. Now, what is the value of V1? V1 is equal to, careful, V1 is equal to, current entering is positive, that's fine. So I'll have plus L di by dt. V1 is equal to L di by dt. Already I have given here. Here we got in terms of reactance. I don't have to write in terms of di by dt because I directly got reactance here. So V1 is equal to J4 into I1. J4 into I1. Next we have this term plus, careful, plus J2 into I1. Should I write plus J2 into I1? No, it's a mutual because of this current. I1 minus I2. Substitute this here, that's it. Now coming to V2. V2 is equal to, now V2 again current entering is positive, that's fine. So you'll get there will not be any change. J5 into I1 minus I2. Okay, then coupling plus J2 into current is this current plus J2 into I1. Okay, substitute V1 value here, V2 value here, and simplify it, you will get something. Okay, substitute V1, V2 here and simplify in a simplest form. If I have an equation, I'll give it. I don't have the simplified equation. Okay, so I simplify it. It's a simple thing which you can do it already very easily. I'm not wasting my time because I can cover more questions. I have a lot of questions to discuss. Okay, I'm not spending time on simplifying this. Now coming to the second loop. This is the second loop. For this loop, careful guys, for this loop, if I go this way, what I'll have? Minus V2. This is a minus V2. Careful with this. Minus V2. Then plus V3. If I take this one as V3, minus V2 plus V3. And current is I2 here. Minus J2 into I2. Minus J2 I2 is equal to 0. Minus V2 plus V3 minus J2 I2 is equal to 0. Okay. You already have equation for V2. Substitute here. Now we need to write equation for V3. Let's do it. V3 is equal to, no, it's not getting visibility, is lost. Yeah, V3 is equal to, let me write here V3. V3 is equal to, this is done. Tell me V3 is equal to what? Current entering is positive, we have taken properly, so I can directly take J6 into I2. Self-induced EMF. Mutual induced EMF, there is a mutual coupling between these two, a negative sign, minus J3 into this current I1. Now V2 is known, V3 is known, that's it, you will get an equation. Sir, how can you calculate the equivalent inductance of a single phase induction motor if it runs on, it's, again, you are out of the scope of this video. I think I'll discuss these in machines maybe. Okay, you're talking about this purely, it's a machine topic. Okay, maybe we'll discuss in PISQUAREYT video or other general video. Okay, now, so this is the equation. This is how you need to write equations for KVL equations for these two. You should be careful with these inductors. When you write this way, it will avoid a lot of confusions. If you don't write this way, I'm pretty sure you'll be trapped somewhere. Okay, follow this method. Method is important here. Now, look at this. Solve this. Consider the following statements in the circuit shown figure. If the equivalent impedance between X, Y is equal to Z equivalent, then what is the value of Z equivalent? And what is the relation between I1 and I2? Out of these, which one is correct? Okay. Question, you should understand the question properly. So first find what is the value of Z equivalent. Now for these kind of circuits, how do you find a Z equivalent? If these dots are not there, if there is no mutual coupling, then I can easily find out Z equivalent by series. These two are in series, these two are in series, and this setup in parallel. I can do series parallel combination. But now, how can we do? How can we find the equivalent impedance for this kind of series parallel combination? For series parallel combination, the only way is test source method. Means some voltage, you'll think some voltage is there. Ohm's law, simply Ohm's law. If there is some voltage here and corresponding current, we know Z is equal to V by I. So by using this Ohm's law, means this expression, you'll find what is the impedance. Now, how do you get this expression? That's an important point. So you take some voltage, take some current I, so corresponding current is splitting into I1 and I2. Write KVL equation for this loop. For this loop, write KVL equation. Or maybe for this loop, not complete loop, we don't have to write for complete loop. For this loop, we can write KVL equation. And for this loop, we can write KVL equation. For these two loops, you write the KVL equation. Or else, you can even do for this also, not a problem. You can even do for this super mesh also. That will be easy one rather. So anyone you can do it, any two equations you write it, then you will get this form. Let's do it. For this, I am writing KVL equation. this is plus, this is minus. You write KVL equation for this. So far I have discussed a lot of KVL equations, right? Now for this you write KVL equation. For this you write the KVL equation. Plus minus, so for loop 1 I am writing with red, minus V at an angle some 0, okay, and this current is I1. I1 is so plus I1 into 4, plus I1 into 4, plus this will be some V1, this will be V1, so plus V1. Now what is the value of V1? Let me directly write it. So far I am writing in different ways, so I am writing now directly. The value of V1 is J10 into I1. Type of coupling, when you have this you need to write here coupling, type of coupling, positive or negative, current entering at a dot, here current entering at undotted or current leaving at dot, it's opposite, so negative coupling, minus here. So minus J4 into this current I2 is equal to 0, is equal to 0. This is the first equation. The second equation, I can take this mesh also, or I can take super mesh. If you take this also you will get it, but I think it will be easy to analyze now because only this loop is there. I'll take this. I'll take this. For the convenience, it will be easy. You can quickly solve it. How will know all this stuff? Just with the practice you will get it. Okay. Minus V plus I2 into 4 plus I2 into 4 plus V2 plus V2. This is V2 plus V2. The value of V2 again, value of V2, current entering at this point, that's what we have taken as positive. So you'll get again self-induced EMF is positive, J10 into I2 minus J4 into I1 is equal to 0. Is equal to 0. Now from this I can write V is equal to this way. I can write V is equal to this. V is equal to this. I can equate these two. This is also V is equal to this, this is also V equal to this. I can equate these two. I can equate these two. When I equate these two, I'll get an interesting relation. You just equate it and solve it. You will get these two get cancelled, these two get cancelled. I mean, when these two will be equal, you check it. When these two will be equal, this is I1, this is I2. When these will be equal, this is 4, this is 4, this is 10, this is 10. Minus sign, 4, 4. Numbers are same. These are having some variables. Only if, without solving also I can do it. Only if I1 is equal to I2, then only this is possible, otherwise it's not possible. A simple, aptitude skills if you are good with, you can directly answer it. If I1 is equal to I2, then only it is possible, otherwise not possible. This equation will not be possible except at these points, at this condition. So 4 is correct, 3 is wrong. I1 must be equal to I2. So 4 is correct, 3 is wrong. So this is not the possible answer, this is not the possible answer. Any one of these two are the possible answers. Okay. Now you need to find the Z equivalent. Now substitute in place of here, in place of this I2 here, you substitute I1. You substitute I1. And what is the relation between I1, I2 and I? I is equal to I1 plus I2. Now I1 is equal to I2, so I can say I is equal to 2 into I1. Sorry, V by I means what? V by 2 into I1. V by 2 into I1. Now you need to find V by 2 into I1, that's the value of Z. V by 2 into I1, that's the value of Z. Now I'm just erasing this. Now in place of I2, in place of I1, sorry, I2, in place of I2, I1 is there. Now simplify it. I1 take common, I1 V by I1 is equal to, V by I1 is equal to 4 plus J6. 4 plus J6 is V by I1. But what I want impedance, means I want V by 2I1. Divide this with 2, so this also divide with 2. You will get 2 plus J3. So 2 plus J3 is equal to V by 2, that's what is equal to Z. 2 plus J3. So these are one. These two are correct, means B is the right answer. Yes, Mahesh, you're right. I think points are clear. They are the point. This is a technique. This is a technique. Here, finding V1 and V2, the voltage across inductorism may only point, you should consider, you should be careful, you should be careful with only this. Okay, the next one. Yeah, find the power lost in 1 ohm resistor. Find the power loss in this 1 ohm resistor. How much is the power loss in this? Do this amount. How much is the power loss in that? Solve it. Right, find out the current. You need to find out the current I2. Once you find out the current I2 into I2 square into 1 is the power loss. Power loss is equal to what? I2 square into R. R is equal to 1. So power loss is equal to I2 square. P is equal to I2 square. So once you find I2, you can get power loss. How to find I2? Write KVL for this, KVL for this. Both KVL equations, you solve it, you'll get it. Simple. Give it a try. KVL for this. First look for this, you do it, then we'll go for the second one. Minus 50 at an angle 0 degrees. Here 50 is, careful, maximum value, because it's a maximum value. Careful with this. Always when you're writing it, you should be careful whether you're using a maximum value or RMS value. Okay. So all the values what you'll be getting, they will be all the results what you'll be getting in terms of maximum, because I used a maximum voltage. Next, plus, I'll use blue. Plus 2 into I1 plus some voltage V1 is equal to 0. This voltage V1 is equal to 0. Value of V1 is in 2 terms. Here, whenever you see this type of coupling, tell me whether it is a positive coupling or negative coupling. I'm waiting. Tell me whether it is a positive coupling or negative coupling. No response. Current entering a dot, here current leaving a dot, this current is leaving a dot. Yes, it is a negative coupling. Put this sign here. That's the first thing you should do. Now V1 is equal to J2 into this current I1 and minus J1 this current I2, minus J I2 is equal to 0. Okay, this is the first equation. The second equation, this is the second equation. Plus minus, this is V2. Careful with this, this is plus and minus. Okay, plus and minus V2. Now current is leaving here, let me write KVL equation for this. Minus V2 plus I2 into 1, that is I2, plus 1 by 2 farad. Shall I use here 1 by 2? No, it isn't farad. You need to convert this into ohms. Okay, so omega is 2, 1 by 2 farad, 1 by 2 into 2, that is 1 minus J1. You have to use minus J1. I2 into 1 minus J1 into I2 is equal to 0. Okay, now you should be careful in writing a V2 equation properly. Okay, V2, look for this V2. Take this one as, or else let's go to the standard one. Current here, current is leaving, so current must be entering here. So let me take this as positive. According to us, this is supposed to be positive, this is supposed to be negative. Let me take this one as Vx. That is Vx. Okay, let's find Vx. So Vx is equal to minus V2. So in place of this, I think minus V2, I'll put directly Vx. Okay, that will be easy one. This is the equation. Now Vx value, how do you find Vx value? Vx is equal to, current entering is this, Vx will have two terms, J4 into I2 is the positive one, because passive sign convention is followed, plus J4 into I2, that's fine. I2 is entering it undotted, I1 is entering it, that's what, we already done it, negative coupling. So let's use that, minus J1 into I1, minus J I1. Okay, so this is the second equation, this is the first equation, this is the second equation. Okay, if you have, how many unknowns are there? 2 unknowns are there, 2 equations, 2 unknowns, you can easily solve. I don't think you will face any problem in solving these 2 equations. Okay, so right here, it's a complex numbers, so I1 in terms of I2, you write it, I1 in terms of I2, can you write it? I don't have it, otherwise I would have given. Let me solve it, minus J4 into I2, here we have minus J, sorry, plus J, minus J, we have, this is 1, I2 into 1 plus J3 minus J I1, that's it. So I can say minus is equal to 0. If I take minus to the other side, equal to 0. So in place of I2 I can keep, in place of I2 I can keep, in place of I2 I want I2, right? In place of I2 I can keep J I1 by 1 plus J3. Okay, I'll have this equation. If you solve it, you solve these 2 equations, substitute I2 value here, then you will get I1. Then after that you can find out I2 also. I'm giving the values. After solving this equation, I2 is equal to, you will get it as 9.434 ampere. If I'm not wrong in calculation, this is supposed to be the answer. If I'm wrong in doing the calculation, there will be different answer, but process, right? What is this value? Point here to notice, what is this value? That is a maximum value. I2 max, because we have taken maximum, so this is a maximum value. But what I want, power is equal to I2 square. This I2 must be RMS value. Okay, but here I got maximum value. I want to convert maximum value into RMS value. How do you do it? We have a sinusoid, relation is root 2. So I2, this is maximum, I2 RMS will be equal to 9.434 by root 2. You will get 6.67 ampere. Okay, is this a power? Power is 6.67 square. If you square it, P is equal to I2 RMS square is equal to 44.5 watt. This answer. Okay, try to be careful in just finding V1 and V2, which is very crucial. Okay, that's the first and foremost thing you should remember. That's what the main summary of this specific lecture. Okay, first step is, for every coupling, any type of coupling you have, for every coupling type, identify type of coupling between the inductors. That's the first thing you're supposed to do. Between the inductors, you identify the type of coupling. If it is a positive coupling, write, when you are having this arrow like this, write there minus. If it is positive coupling, write here plus. If it is negative coupling, write there minus. Okay, then that will be easier. That's the first one. The second one, be careful with coupled inductor voltages. Coupled inductor voltages. Okay, when you want to find coupled inductor voltage, you should be very cautious, because it has 2 terms at least. If it is more coupling, if there are more number of coupled coils, as many number of couplings it has, that many number of EMF terms will be there. One self-induced EMF. If it has one coupling, then another mutually induced EMF also. If there is no coupling, uncoupled inductors, then only self-induced EMF will be there, no mutual induced EMF. That is the second point you should keep it. The third point what you should keep, finding equivalent impedance. For finding equivalent impedance, you have to write KVL equations. You have to use KVL equations properly to find out equivalent impedances. Finding equivalent impedances has a close connection with KVL equations. Okay, that's it for this session. I hope you got some good insights, but still I'm pretty sure, because the topic itself is a little tricky topic. If you don't watch multiple times, I don't think you're going to get the complete essence of it. Okay, so try to watch multiple times. That's a point. That's a point what I want to say. Thank you guys. Thank you for joining me live, and try to watch it multiple times. And if you are new to the channel, subscribe to the channel. And if you want more classes of this style, there are already Unacademy Plus is going on. The live classes are going on with different doubt clearing sessions, regular doubt clearing sessions. All these things are happening. Okay, you can just check it. Go for it. Just give it a check. There are free classes also. Okay, free classes by top educators. Try those free classes. If you like it, yes, what's wrong in going for it? Okay. So if you like the classes, if you want to use my coupon, PISQUARE is a coupon code. PISQUARE is a coupon code. PISQUARE, QARE. I forgot. If you use this coupon code, you will get a maximum possible discount also on a plus subscription, because they are the paid courses. For the paid courses I'm talking about. Okay. So just first check it once. You will definitely like it. Then you can choose a plan which is most comfortable for you. That's it. See you in the next class with another interesting topic.